Now there's another person, and he practices on the same motorbike. So we know something about the motorbike. It can give us 240 newtons of force on a track, but this track has got an incline. Now, starting from rest, the person rides a distance of 450 meters up the incline, which has a vertical height of 5 meters. So there, we're not given the angle of the incline, so we don't know the angle, but we know that he travels 450 and goes up 5 meters. So it's a very slight incline, but an incline nevertheless. What are they asking us? The total frictional force acting on the motorbike is 249 newtons. Okay, we'll go back here, and there is a frictional force, and it's kinetic friction because this body is moving. It's 294 newtons. And the combined mass of the rider and the bike is 300 kilograms. The average driving force of the motorbike as it moves up the... he's turned on the power a little bit. He's not just using the 240 that he did on the flat. It's 350. Consider the motorbike and the rider as a single system. Okay, let's just go back. This has got a mass equals to 300 kilograms, and we're not separating the two things out. In physics, of course, free body diagram, if we looked at the forces, we'd make both the bicycle, the bike, and the mass. We'd just make it a dot because we're not interested in all the intricacies here. It's just a mass of 300 kilograms. We're interested in the forces that act on it. Draw a labeled free body. Here it is. We're asked for the force for the motorbike rider system. So we start with our dot. That is all the bodies and the masses involved. Now what I'm going to do is I'm going to draw a dotted line here just to show the direction of the incline. Now, what forces are going to involve? Well, we know that there is going to be a weight. Okay, that weight, and that weight is going to be the force of gravity. We know that from the surface there will be a normal force. Okay, there's a normal force, and we also know that this normal force is going to be something to do with a component of the force of gravity. But I don't, in a free body diagram, have to put in the components. I'm just reminding myself I know that it's there. We are told, and this would be true of any system, is that there is a frictional force acting over here. We know that's going to be mu k times the normal force, which we've seen here. And then, of course, there is the driving force, which is directly up the plane, and we'll call that FD or F applied force, any of that. And all of this is on a system which is represented as a dot in a free body diagram, and there it is. So that's how many marks do we get for that? 4 marks. Money for jam. 1 mark for that. 1 mark and yeah, you show the weight, all that. 1 mark for that, 1 mark for that, 1 mark for that. And of course, getting that mark, you would have to show that this is at an angle down the plane. You have to show that this is up the plane, parallel to the plane. You have to show this is at right angles to the plane. You have to show that this is vertical, going down towards the center of the earth here. So once you've got those directions right, you are fine. You don't have to give the values. Although if you did give the values, it'd take you a little bit of time, but you won't lose marks for it. So there's 4 marks. You really should be able to do that in 4 minutes.